In this video, I'll describe lunar phases and lunar and solar eclipses. There's a lot going on in this figure. Let's start with the names of the different phases of the moon. Look at just the outer images of the moon. These show how the moon appears in our sky. Let's start on the right side and move counterclockwise. In many traditional calendars throughout the world, including the Chinese, Hindu, Jewish, and Islamic calendars, the month begins with the new moon. A new moon literally meant that you saw the moon for the first time after it had disappeared for a couple of days. But today in astronomy, we use the term new moon to mean no moon. A day or two later, the moon will appear as a thin crescent, what they used to call a new moon. It's called a waxing crescent. Waxing means increasing. In the northern hemisphere, the crescent will be on the right side of the moon. Then every day, the bright portion of the moon will get a little larger. Roughly 1 week after the new moon, half of the moon will be bright. This is confusingly called a first quarter moon. It's half full, not a quarter full, but it's completed 1/4 of its cycle. Over the next week, when it's between half full and full, it's called a waxing gibbous. Then we have a full moon. Then we get into the waning or decreasing phases. Now the bright portion of the moon is on the left side, again, if you're in the northern hemisphere. When the moon is between full and half full, it's called a waning gibbous. When it's again half full, that's third quarter, which is sometimes called last quarter. And then it's a waning crescent, and then the next new moon. So again, less than half full is called a crescent, more than half full is called a gibbous, and half full is confusingly called a quarter. And for us here in the northern hemisphere, when the bright portion is on the right side, it's waxing, and when it's on the left side, it's waning. Now look at the images labeled A through H. These show where the moon is relative to the earth during each phase. Notice that the right half of the moon is lit up in all of these images. That's because the sun is on the right. The bright side is the daytime side of the moon. Just like the earth, half of the moon experiences daylight while the other half experiences night. So the bright side is the sun-facing side, and the dark side is the side facing away from the sun. Don't confuse that with the near side, or earth-facing side, and the far side, which is the side facing away from the earth. The phase of the moon we see from Earth at any given time depends on how much of the near side is bright. If it's a new moon, none of it is. Then the near side is the dark side, and the far side is the bright side, which here is at position A. During a full moon, which is at position E, the near side is the same as the bright side. At that time, the Earth and the Sun see the same side of the moon. To keep this from getting too tedious, I'll let you figure out the position of the moon relative to the Earth and the Sun for all of the other phases. So look at the other letters, B, C, D, etc., and make sure you understand why each position corresponds to the phase we see in our sky. Now I'd like to point out a couple of other things. Notice that the full moon faces the nighttime side of the Earth. So a full moon is always up at night. It's on the opposite side of the sky as the sun, which means it rises around sunset and sets around sunrise. A new moon faces the daytime side of the Earth. It rises and sets around the same time as the sun. Not only is the near side dark at that time, the moon is also close to the sun in the sky, making it pretty much impossible to see. What then is an eclipse? It's when the Earth casts a shadow on the moon or the moon casts a shadow on the Earth. You might expect the Earth to cast a shadow on the moon every full moon, but it doesn't because the orbit of the moon is slightly tilted relative to the orbit of the Earth. The path of the Earth around the Sun is called the ecliptic. The path of the Moon around the Earth is tilted by 5 degrees relative to the ecliptic. It crosses the ecliptic roughly twice a month, once going down and once coming back up. And each time it happens, the Moon is in a different phase. A couple times a year, it happens during a full moon, and so we get a lunar eclipse. There's a figure showing this in the book, but I didn't think it was as helpful as this one, which I found online. Don't worry about the difference between the total shadow, which is called the umbra, and the partial shadow, which is called the penumbra. Also, don't worry about the different stages shown, such as penumbra 1, umbra 1, etc. In summary, there are 2 requirements for a lunar eclipse. It must be a full moon, and the moon must be crossing the ecliptic. That's why the word eclipse and the word ecliptic sound so similar. Eclipses happen when the moon crosses the ecliptic. And it's a full moon in the case of a lunar eclipse. If you happen to be on the nighttime side of the Earth when the lunar eclipse happens, then you'll get to see it. Actually, more than half the Earth will get to see it because the Earth will turn while the eclipse is happening. And here's how it'll look. Before the eclipse begins, you'll see a full moon. Then it'll look like a bite was taken out of the moon. It doesn't quite look like a gibbous moon because in a gibbous moon, the terminator, which is a boundary between the bright side and the dark side, is curved the other way. Then it looks a bit like a quarter moon and then eventually a crescent. Finally, during totality, the moon becomes faint and red. It doesn't fully disappear because some sunlight scattering off the Earth's atmosphere still hits the moon. The blue light from the sun scatters in every direction, while much of the red light from the sun is bent towards the moon. Totality will last for about an hour. Then it'll be a partial eclipse again, and back to a full moon. Here's timeanddate.com's list of total lunar eclipses during the 2020s. I didn't include the penumbral eclipses and the partial eclipses. Penumbral eclipses are hardly noticeable. Partial eclipses, I don't find that impressive. As you can see, at least once every couple of years, there's a total lunar eclipse visible from our part of North America. If it happens during a warm season, you can throw an eclipse party. You can check out the moon once every 10-15 minutes and then get back to partying. Now, if the moon happens to be crossing the ecliptic during a new moon, we get a total solar eclipse, or it could even be a partial solar eclipse. This also happens roughly twice a year, but since the moon is much smaller than the Earth, the moon's shadow only falls on a 100-mile wide region on the Earth. You have to be at that one spot to see the solar eclipse at that time. And at that spot, the eclipse will only last a couple of minutes. As the Earth turns, the moon's shadow will drift across the Earth. So anyone that happens to be in a 100-mile wide strip that runs across a continent or an ocean will get to see the total solar eclipse at some point that day. The last time North America was in the path of a total solar eclipse was on August 21st, 2017. The path of totality didn't cross Chicagoland. From here, you could see up to 90% of the sun's disk eclipsed. I'd seen an eclipse just like that from Singapore in 2016. I didn't have eclipse glasses then, so I just bought a welding mask, and that worked just fine. But even when the sun's disk was 90% eclipsed, the sky didn't get noticeably darker and it didn't feel any cooler. My family and I were out at a playground, taking turns looking through the welding mask. A few strangers stopped by and took a look, but plenty of other people were just going about their day. For me, this was a pretty interesting phenomenon, the partial solar eclipse, but not exactly life-changing. So I was determined to see the 2017 eclipse in totality. It turned out to be the first day of fall semester, and there was a big eclipse viewing event at Harper, but I wasn't there. I showed the people organizing the event how to use their telescopes and our solar filters, and then said, "See ya!" And none of the other astronomy instructors were there either. We all headed to different spots in the path of totality. My family and I went to Missouri. And for 2 minutes, this is what we got to see. The disk of the sun is a layer called the photosphere. During a total solar eclipse, the photosphere is completely blocked by the moon. And so the fainter outer atmosphere of the sun, which is called the corona, becomes visible. And it's a spooky sight. The sky turns dark enough for planets and some bright stars to become visible. It gets chilly. Crickets start chirping. And everyone just freezes for a couple of minutes. If you haven't experienced it, I'd highly recommend it. Here's NASA's map showing where total eclipses can be seen from 2021 to 2040. The red strips are annular eclipses. During an annular eclipse, the moon doesn't fully block out the photosphere. Both the moon and the Earth have slightly elliptical orbits, so both the moon and the sun can be slightly larger and slightly smaller at different times. At least that's how they appear to us. Of course, their physical size doesn't change, but their angular size, which is the apparent size that we see, can get slightly larger or smaller. When the moon's a little smaller in the sky and the sun's a little larger in the sky, we get an annular eclipse. It would look cool with eclipse glasses. You would see a ring of sunlight around the moon, but the sky won't turn dark. You won't see stars and planets. It's not nearly as dramatic of an event as a total solar eclipse. So I'm not going to go out of my way to see an annular eclipse. I'm into total eclipses. Those are the blue strips. In North America, we'll again have a total solar eclipse in 2024. Mark your calendar for April 8th, 2024. Again, the path doesn't cut through Chicago, but you don't have to drive too far to see it. And if you'd like to travel, you can try to time your trip with a total solar eclipse. There'll be 3 happening in Australia in the next couple of decades. One of those will be cutting through South Africa. There are 2 that cut through Egypt and Arabia. There's one that goes through northern China and Japan. Here's another one that goes through Iceland and Spain, and so on. Perhaps you'll see the 2024 eclipse, decide this is it, and become a globe-trotting eclipse chaser.